Students, we will start the chapter number 10, gravitation. Okay, so in stand that is a chapter 8 and 9, as we have to study that force as the can change the motion. Okay, so here force is needed to change the speed. It can change the speed, it can change the shape, it can change the direction. Okay, so here that is we always that is we know that as we know that object dropped from certain height, okay, and it attract towards the earth. So here all the planets, as we know that all the planets revolve around the sun, as well as moon revolve around the earth. Okay, so in all these cases, okay, that is one type of force acting on this object. Okay, and this force is known as the gravitational force. Now, gravitation, that is, as we know that the moon revolve around the earth. Okay, the moon revolving around the earth, and objects when thrown upward direction. Okay, that is, it reaches a certain height and then falls downward. Okay, if you throw the ball, okay, tennis ball or any plastic ball throw in the sky and attains a certain height, and afterwards it comes in downward direction. Okay, so here, so when Newton was sitting under the tree, okay, an apple fell on him, and the fall of the apple made Newton start the some question will be arises thinking in his mind, and he thought that if the earth can attract an apple, can it not attract the moon? Okay, can it not attract the moon? So for that, afterwards they give the explanation about such type of the question. Okay, so for that, first we have to discuss the activity 10.1 first, and afterwards we give the answer. So here in this activity, that is, we have to take the one piece of the thread. Okay, kite thread you to take, and tie the small stone at the one end, and the other end you have to be hold with your fingers. Okay, and wheel it over your head. So there is stone will be rotate. Okay, motion, that is circular motion we can be obtained. Now you have to slowly release the thread. Okay, slowly release the thread. So, and again note the direction of motion of the stone. So here, before the thread is released, the stone moves in a circular path with certain speed. Okay, when thread is released, the stone moves in a circular path with constant speed. Okay, certain speed, and change the direction at each and every point. And the change in direction, that is involve change in the acceleration. Okay, here the change in direction, okay, direction will be a circular path, so direction will be change each and every point. Okay, and due to this, the change in direction involve the change in the velocity as well as the acceleration. Okay, now as we know that what is the acceleration, do you know acceleration? So acceleration nothing but the rate of change of the velocity. The rate of change of velocity, it is known as the acceleration. Here, the force that cause this acceleration and keeps the body moving along the circular path, okay, acting toward the center, okay, and this force is known as the centripetal force. Okay, again, the force that causes the acceleration and keeps the body moving along the circular path is acting toward the center, and this force is known as the centripetal force here. Okay, here we discuss about the motion, that is motion of the moon around the earth, as we know that. Okay, the motion of the moon around the earth is due to the centripetal force, and the centripetal force is provided by the force of attraction. Okay, force of attraction of the earth. Okay, so there is a force between the moon and the earth. So there is one type of force will be attractive between the moon as well as the earth. Okay, So here, that is Newton's arises the some question, that is some that is a falling apple is attracted towards the earth. Okay, fall is downward. Okay, why not go in upward direction? Because earth attracted towards it. Every object attracted towards the earth. Okay, so here Newton writes, does the apple attract the earth? Does the apple attract the earth? Because here earth attract, that is apple can attract the earth. So no. Afterwards they give the explanation why they cannot be attract, or apple cannot be attract the earth. So according to the third law of motion, the apple does attract the earth. Okay. Previously we discussed about, that is previous chapter, that is according to third law of motion. Okay, in chapter number 8, that is the apple, that is apple does attract the earth. Okay, every object attract towards the earth. So here, according to Sebert's, according to second law of motion, that is F is equal to ma. Okay, mass into acceleration. Force is directly proportional to the product of mass into acceleration. So acceleration is equal to F upon m. Okay, if we take the equation, that is F is equal to ma, second law of motion. Okay, so A is equal to F divided by m. Okay, so here the mass of an apple is negligible. Okay, compared to the earth. Compared to the earth, mass of an apple is very small. That is negligible. Okay, and according to the F is equal to ma, that is second law of motion. It gives the force, that is acceleration is inversely proportional to the mass. That is A is equal to F upon m. Okay, so here the mass of an apple is negligible compared to the earth. Okay, earth mass is very large, as we know that, but compared to the apple, the mass of apple is very small. Okay, negligible. Okay, and due to this reason, we do not see the earth moving towards the apple. Okay, for this question answer, we do not see the earth moving towards the apple, because mass of an apple is very negligible compared to the earth mass. Okay, and according to the second law of motion, the acceleration is inversely proportional to the mass of an object. Okay, F upon m, that is A is equal to F upon m. And due to this two reason, we cannot be see, that is the earth moving towards the apple. Now in our solar system, that is as we know that all the planets revolve around the sun. All the planets revolve around the sun in our solar system. Here, that is, there exists one type of force between the sun and the planet. Okay, the sun is the center and all the planets revolving around the sun, because of one type of force is acting towards the, that is centripetal force, as the gravitational force of the sun. Okay, sun has the more gravitational force compared to the all other planets. Okay, and for this reason all the planets revolving the sun. So there exists a force between the sun and the other planets. So Newton conclude that here all the objects in the universe attract each other. Okay, finally, that is Newton conclude that all from all this experiment, and conclude that all the objects in the universe, okay, all the objects in the whole universe attract each other, and this force of attraction between the object, it is known as the gravitational force. Okay, all the objects in the universe attract each other, and this force of attraction between objects is called the gravitational force. Okay, understood all of you? Now, that is next universal law of the gravitational we discuss. Universal law of gravitation. So here, uh, as we know that as previously, force is directly proportional to the product of their mass. Okay, force is directly proportional to the product of mass, and force is directly proportional to inversely square of its distance. Okay, so every object in the universe attract each other. Okay, with a force, and which proportional to the product of their masses. Okay, product of their masses and inversely proportional to square of its distance. So for that, we let us consider that is two objects, that is object A and object B. Okay, object A and object B. Let us consider. Let object A is the earth, okay, having the mass capital M, and object B, it is considered it is an apple, that is small, okay, compared to the earth. Okay, B object is an apple and its mass is small m, and the distance, that is D is the distance between the centripetal, that is from the center of the earth and center of the apple, the distance will be D. Okay, so here as shown figure, like the force of attraction between the two objects. Okay, force of attraction between the apple and the earth. Okay, force of attraction, let force will be capital F. Okay, now according to the universal law of the gravitation, the force between two objects is directly proportional to the product of their mass. Okay, product of their mass, that is capital M, that is mass of the earth, and small m, mass of an apple. So M multiply by M. Okay, force directly proportional to the, see the equation first, force F proportional capital M multiplied by small m. That is, force is directly proportional to the mass, okay, mass of an earth and mass of an apple, okay, product of their mass, okay. And the force between two objects is inversely proportional square of its distance between the earth and the apple. So F proportional 1 upon d square. It means that force is directly proportional to the inversely proportional square of its distance, F proportional 1 upon d square. Now from equation 1 and equation 2 combine to each other, okay, and we obtain that is F proportional capital M small m divided by d square. Okay, combine equation 1 and 2. So here, that is proportional. Now here we remove the proportional, we have to add some constant, that is capital G. Okay, we have to remove the proportionality sign and we have to add capital G, proportionality constant, that is F is equal to G, M, capital M multiplied by small m upon d square. And here capital G, it is known as the constant proportionality. Okay, it is known as the universal gravitational, capital G is the universal gravitation. Now here cross multiply, okay, F multiply by d square, okay, cross multiply in this equation 10.4. Okay, see the observe 10.4, cross multiply by F multiply by d square is equal to Gm multiply by M. So you obtain this equation. Okay, F d square is equal to Gm multiply by M. Now we obtain capital G. Okay, so small, that is capital M small m, it will be come in downward. Okay, so that is F d square upon capital M multiplied by small m equal to G. Okay, understood? Okay, F multiplied by d square upon divide नीचे लाई दो, small capital M multiplied by small m is equal to capital G. Okay, so this equation we will obtain, that is from this equation, that is obtain, that is a SI unit. Okay, SI unit we discuss about. Okay, G is equal to F d square. Okay, F into F multiplied by d square upon M multiplied by M. So force, the SI unit of force will be Newton. Okay, now D is equal to distance. D is the distance between two objects. Okay, distance between the apple and the earth, it is small d. Okay, and this d is measured in meter. So here d square is equal to, that is meter square. So Newton meter square divide by here mass of an earth. Okay, and mass of an apple, so mass will be measured in SI unit, that is kilogram. So kilogram into kilogram, so kg square. Okay, so SI unit of capital G will be Newton meter square into kg raised to minus 2. Okay, force measured in Newton, distance measured in, that is d square equal to meter square, upon m multiplied by, that is kilogram into kilogram, that is kg raised to minus 2. So the SI unit of universal gravitation G, that is n Newton meter square kg raised to minus 2. Now here the value of G, that is the gravitational constant, okay, it will be found that Henry Cavendish, first time Henry Cavendish measured the value of the capital G using the sensitive balance, okay, and obtain the value, that is capital G, that is 6.67 into 10 raised to minus 11, okay, the value of the capital G, that is universal gravitation constant, its value is 6.67 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Okay.